Today, we discuss the third module of cloud computing, security architecture for trustworthy cloud computing. First, I give a brief introduction. Then, we discuss security challenges. The last topic will be Cisco Cloud Reference Architecture Framework. Cloud computing has caused a disruptive shift in technology. This shift has and will continue to revolutionize the way businesses acquire and deliver information technology service. Business architectures prior to cloud computing look toward the cloud infrastructure to update and integrate cloud solution into their current architecture. The cloud infrastructure provides infrastructure as a service, platform as a service, and software as a service in a distributed environment. We discussed these three services already. Client share resource and the storage of data in a data center. Resource will include software and all the hardware. The way cloud computing operates causes various threats and possible security issues. The internet is the main driver in all operations for cloud computing services. The internet is also a host for malicious content and action. The impact of this threat and attack can range from data leakage to identity fraud. Actually, it's much, much more than we mentioned here. Let's talk about the security challenge in cloud computing. The first one, I like to discuss a little bit of data privacy and security, right? When we talk about that, they include confidentiality, integrity, and availability. There are three key issues in information assurance and cloud computing, actually all the network-related system. We repeated the three definitions here. Confidentiality gives customers the reassurance that the information that is being stored offsite that can only be accessed by authorized persons. That's the confidentiality. Integrity of data that is transferred from one location to another location is guaranteed that the data has not been corrupted or tampered within any way, and to keep the data in its original format, right? Like we don't use cloud computing, we still have that kind of problem because the hacker can get the student or the teacher or your bank account issue. Recently, Facebook looks like have some issue. Availability is the data available when it is needed. Means anytime you want to retrieve the data, you want to check it, you want to look at it, that can be guaranteed any moment in any location you can access them. These are three challenges in the data privacy and the security: confidentiality, integrity, and availability. The following we discuss very briefly how we can do it. Keep all cryptographic algorithms up to date. We know that we have public key cryptographic, private key cryptographic, different cryptographic algorithms because the hardware and software develop so fast. Also, hackers constantly develop new methods to attack our system. Therefore, keep all cryptographic algorithms to today is the best way and easier to protect your data. In the case of a developer using cryptographic algorithms, they are not up to date can result in exposing pertinent data that was encrypted but can be compromised. This presents a challenge in the case of information leakage for the cloud provider and the customer's information which has been victimized. For example, we have the applied credit card, right? If somebody gets your information, use your credit card, who should pay? It will book on your credit card. If the developers are not aware or concerned about these changes, the security risk will continue to increase where attackers are looking for specific vulnerability, deal with the unsuitable cryptographic algorithms. So now this is based on our previous research. We categorize the security challenge in the cloud computing like this. We categorize in a few ways. One, external threats. Two, guest-to-guest threats. Three, cloud-to-guest threats. The four is guest-to-cloud threats. We will discuss in the following. This is briefly is the cloud computing, right? We have cloud management infrastructure, we use it. We have multiple custom, we have virtual machine, each customer run on your virtual machine. We talk about the configure, we get a resource from cloud computing. Then when we finish it, we release the resource back. So let's discuss each individually now. First, we discuss external threats. A hacker that exploits vulnerability in service provided to a customer pose external threats that both the customer and the provider must be aware of. External threats can be categorized by attackers that occur outside a consumer's domain. So we can list a few pages. In here, I just list a few common ones. I'm sure every student know already. Man in the middle attack, packet sniffing, IP spoofing, denial of service attack, right? We can list a lot. In general, in the normal internet, we can see this threat. I categorize this as external threats. Okay, I pick up a few, we discuss it. Man in the middle attack happens when a malicious user deploys a proxy application in between a consumer and a provider without them knowing, and the attacker intercepts personal information such as login, credential, credit card information, etc. You can list. The man in the middle attack actually can create a multiple different formats. This is just a very brief description. A malicious user can capture and analyze the data in the packet sent over network by packet sniffing. IP spoofing occurs when a malicious user impersonates a legitimate user IP address where they could access information that would not have been able to access otherwise. So this is a very brief description here. Now we discuss the new security challenge in cloud computing called guest-to-cloud threat. So from this word, we know the guest will create some threat to the cloud computing infrastructure. Guest-to-cloud threat could possibly be the most malicious type of attack that can occur in the cloud infrastructure. A user attacks the cloud, bring down one or more segments of the cloud, making it unstable. That's the effect. Now, how do we? Guest-to-cloud threat deal with malicious behavior on the guest side. This behavior could include the guest conducting certain attacks that affect the provided cloud infrastructure. The following, I give some example. Some attacks that threaten the cloud provider would be SQL injection, cross-site scripting, right? Knowing data is initially collected from registration applications for cloud services and or trial registrations. The above attack can be used on the guest side application where hackers and other malicious users look to attack. So that's the in guest side, guest create a certain hacker to hack a cloud infrastructure because of guest to cloud threat. How we do that, right? I give two examples here. The first one is modifying the virtual machine image that are stored on the cloud. We know that when we use cloud, we register, we ask cloud computing provide certain service. Let's say I set up a virtual robotic library. When you get this virtual machine image, you use this virtual robotic library, I hide some bad thing inside. When I finish, I will return this virtual machine image back to the cloud service. If they didn't scan it, this bad thing can be given to another guest because when they ask a robotic simulation lab. So detail is a user can store malicious software. So when the image is stored in the repository, other users will be affected by it. So while running a susceptible virtual machine, lower the general security level of a virtual network of a machine in the cloud. Running a malicious virtual machine is similar to move the attack's machine directly into the network. Right now, you can see that a lot of cloud computing systems, when users finish their virtual machine, return the virtual machine image back, they do the scan to solve this kind of problem. The second example is use a treasure horse. A treasure horse is a malicious piece of software that can make a copy of itself, steal information, or harm its host computer system. Also, it is related to use the virtual machine image. Using a virtual machine image as a carrier for the treasure horse makes the attack's job much easier because the virtual machine image encapsulates all software dependencies of the treasure horse. In a sense, this can be a major problem, seeing as once the virtual machine image is infected with malicious software, other users use that same image will be affected. The prevent is use the same method. When the user return virtual machine image back to the cloud computing, the system will scan this virtual machine image, make sure it is not be affected. Other security issue. Insecure interface and API, right? API are used as a bridge between a user and other service because a lot of activity occur on this interface. The possibility of vulnerability is very high, especially in case of constant reuse of applications that may have exposed vulnerability that have not been resolved. That's API related. Another one is militia inside. The centralized location of consumers' data poses a major issue if a person with malicious tendencies infiltrates a cloud provider system. If the provider's security procedures for physical and logic access control do not meet those of consumers. It can allow a malicious employee on the provider side to collect and or modify data that belong to a customer. This is the hardest one. If you have the employee work for the system, try to do some bad thing. My personal opinion, this is the hardest one. Unknown risk profile. In unknown risk profile, security for consumers must not be lost in the benefit from software and hardware services. It is understood that organizations may overlook some security issue if the benefits outweigh the current issue. This is where an unknown risk profile arises because of the unknown exposure when security is only upheld to the bare minimum. According to the Cloud Security Alliance, information about who is sharing your infrastructure may be pertinent. In addition to network intrusion logs, redirection attempts, and or success, and other logs. This is a primary example of why security within the cloud must be upheld as a high priority, for there is always be the possibility of an unknown risk. So that's the security challenge. The second part, we use the Cisco cloud architecture to discuss a few the security related issue, also give us the complete picture of the cloud computing architecture framework. So we look at the Cisco Cloud Reference Architecture Framework. It consists of 5 layers: cloud service consumer, service delivery and management architecture, service orchestration, security cloud data center framework, data center technology architecture. So if you look here, we can see the briefly 5 layers. Top layer, cloud service consumer. Second layer, service delivery and management architecture. The third layer, service orchestration architecture. The fourth layer we've spent more time discussing is called security architecture. From there, we will see following, I show you another diagram. It include 6 components. Okay, the last one is technology architecture. So now let's look at each layer, what kind of function it provides. Look at the first layer, cloud service consumer. Cloud service consumer is comprised of end user and subscribe. These consumers have access to services that are hosted on the network, storage, and the computer block. The consumer's access to this service will depend upon their authorization to access the services provided within the cloud. Once authorized, the consumer have the ability to define, request, and manage service from this layer. So when we discuss the module 2, we see the way from architecture from other company, but same idea, cloud service consumer that provide the application interface, let the customer configure what they need. The second level is service delivery and management architecture. Before a consumer can be provided with the service that they request, there must be some type of management to organize and follow through with the services available and the service that are request. They do certain type of match, right? For example, I ask a 10 CPU, 1 gig megabyte, they will have some function cloud operating system provided to look at the system where this resource can be located to me. This is crucial when consumers begin to define, request, and manage their services. One must know what services are requested by what consumer and the details for those services that are defined by consumer. Service delivery and management architecture is where the infrastructure and the service are managed in order to provide the consumer with what they request. That's the second layer. Third layer, service orchestration architecture. This layer is implemented with configuration repository enabler. The enablers store key information such as a service catalog that allow the consumer to serve themselves. The repository enablers also store asset inventory and resource to service mapping. Service orchestration layer is where the security architecture, data center technology, and the technology architecture layer are integrated to create a service for delivery. So in other words, this layer needs collaboration with the following two layers: security architecture, data layer, and the data center technology. That's really where you security technology, your hardware, your data storage, availability, all this kind of information will be given to the service orchestration. Then they put it all together to satisfy customer requirement. Okay, now we move to security cloud data center framework, right? We said it will have in here, it includes 6 security components. I move to the little further, let you see the relationship between the 5 layer and these 6 security components. This is the architecture. This is the 5 layer we just see before, right? Cloud service, consumer, until technology architecture. Now we finish here, discuss service orchestration architecture. We move to security architecture. Also, they call secure cloud data center framework. So this layer includes 6 important components. These 6 important components we list here. We will discuss a little bit. Also, we see the technology architecture, right? Also in the previous, they're also called the data center technology architecture. These provide all hardware and software in the cloud computing. So I want to make sure every student understands the relationship. The security architecture includes 6 components. We will discuss it. Right after discuss this layer, the last layer, it is data center technology architecture. They include all these software and hardware we will discuss. So now we back to the 5 layer. We finish the first layer, second layer, third layer. Now we reach a 4th layer. The 4th layer includes 6 components. These 6 components is listed here. Cisco Security Cloud Data Center Framework consists of 6 security components, right? Also, they call this is the Security Cloud Data Center Framework. These 6 components include the threat profile, cloud data center visibility, cloud data center protection, cloud data center building blocks, cloud data center control. The last one is cloud data center compliance and SLA. Okay, from here we can see more clearly, right? Each components, what include, that give a little more detail. We go through all the description. Thread file. The thread file contains the threats such as service disruption, intrusion and takeover, data leakage, data disclosure, data modification, identity threat, and fraud. Actually, that is more than this today. The second component is cloud data center visibility. It includes the components of identification, monitor, and correlation. So if you go to here, they give a little bit detailed description here. For this one, they specifically separate these three big functions, same as cloud data center protection, include these three big functions that were discussed. Okay. Each of the components consists of certain factors that all contributed to the cloud data center visibility. Firewall deep pack inspection and digital certificate are included under identification. Intrusion detection, anomaly detection, network management, network flow, data collection, packet capture, and point monitoring and event monitoring make up the monitoring portion. The correlation section covers event analysis and correlation. So that's the three parts that talk about identification, monitoring, and correlation. Okay, let's move to the next one. Cloud data center protection contains three components, as shown in the previous picture. They are harden, isolate, and enforce. The hardened component consists of baseline security, endpoint security, and link and system redundancy. The isolate contains VLAN, virtual machine, firewall access control policy, SSL, that's the secure socket layer, offloading, and the trust secure framework. So the last component, enforce, contains stateful firewall access control, intrusion prevention, endpoint security, content filtering, and L2 protection. That is the cloud data center protection. Okay, now the last components, cloud data center compliance and SLA. SLA, let's see what, okay, we will see what it stands for. There we have the data being handled and its control. So certain requirements are set in place by the consumer and provided in order to reach agreement to make sure requirements for both are met. The service level agreement is in place to enforce this requirement and to make sure that the consumer and the provider remain compliant. That's the last components of the security related. So Now, let's move to the last layer. Let me bring back this bit confused here, right? We talk about this is 1, 2, 3, 4, 5, 6 components. We finish here. We back to previous, right? We finish layer 1, layer 2, layer 3, layer 4. Now we come back a data center technology architecture. Okay, we done these 6 components. We will discuss data center technology architecture with this big picture, all hardware and software we have. Okay. Let me move to the picture. I talk with the picture. You can come back and look at the description. I think that's probably better to understand. Okay, this is Cisco, the data center technology architecture. I'm sure that includes all the hardware and software. So let's look at it according to the previous explanation from column on the left, application software, to the right column, right? IP, NGN, backbone. Give the briefly explain what it is for each column. So this is very complicated, the picture. Oh, I hope this part doesn't keep flow down. I cannot see. Okay, let's look at the application software building block. This block, right? In here, we see subscribe the A, application 1, right? We have second user, subscribe B, that still use the application 1. Now we have the subscribe the A, they have application 2. It's the same idea for all these users. In here, we have cloud infrastructure management platform, right? Human interact with the hardware. So this is Cisco and third-party application. Top is third-party and Cisco. This is all the connected to the cloud computing system, hardware, software, right? These include network and security management. We will see mobile device, storage, area networking, right? The utilization of virtualized resource will include virtual machine when the customer asks. That can include software like VMware and XEN Hyper. So you can ask any resource you want. That's the second part. When we ask a resource, we go to the virtual machine part, right? So you'll see a lot of details. The bottom give more explanation. We have VMware, XEN Hyper. That's the utilization of virtualized resource we can use. The column 3 is vSwitch, right? That will include the Cisco NEXUS 1000V. This machine include the virtual Ethernet module. That module provides networking service to the VM on each virtual machine. Also, the virtual supervisor module that control multiple VEM virtual Ethernet module as one logical module switch. That's the used vSwitch. Okay, next column is the storage, right? And the storage area network, they call SAN, storage and get out that part. Yeah, storage and SAN. They include the software to control this hardware. They give the example list MDS 9000 plus, right? It's the consolidated storage area. So if we look at this column, this is the computing system, the draw big computing. Yeah, all the computing system. Stimulate data center resource to reduce total cost of ownership. We mentioned many times already, right? So if we look at here, we use MDS. Oh, wait, it should be here. Yeah. Unified Computing System Rack or bladder servers. That's really computer hardware. This column gives us access. Access, we can see, includes the port profile, right? That should include the property and the setting to configure virtual interface. If we look at the bottom access, is NENUX 5000, right? With the 2000 fabric extender, that's the access part. Okay, next one is the aggregation. Okay, aggregation looks more complicated, right? Aggregation is very complicated. I cannot remember. We're back to here. Okay, aggregation consists of server load balancing that design to which server a load balances device should send a client request. Also, they have service control, which contain an application control engine. They have security socket layer, which is the protocol for managing the security transmission of message over the internet. We know the 4 layers of internet, right? Security between the transport and the application layer. Virtualize the device context are presented in both aggregation and core components. That's the next column called core. Each configured VDC preserves itself as a unique device to connect the user within the framework of that physical switch. The VDC runs as a separate logical entity within switch, maintain its own unique set of running software process, having its own configuration, and being managed by a separate administrator. So aggregation is quite complicated, provide a lot of function. Okay, next column is core, right? It includes, in the core, it includes global site selection and intrusion detection, secure domain routing, and the line rate net flow make up the peering components. So we have this Cisco use the hardware here and with the peering, right? The last one they call is the Internet Protocol Next Generation Network, IP, NGN, backbone. Okay, there is the infrastructure, video, mobile, cloud, and the Cisco managed service can build up. That list what Cisco use. So this completes the diagram show the Cisco, right? The last layer. It is data center technology architecture. That's how they support it. So this is the last module. We finished discuss all the cloud computing.